Okay, welcome to another OpenStax astronomy video. We will be looking at chapter 10, so Earth-like planets. We'll be focusing on Venus and Mars. And so unlike Mercury, which is fairly dead and no geological activity happening now, we've seen some evidence of perhaps something in the past, and also the moon. Venus and Mars are extremely different, where they are kind of vibrant and alive. So 10.2, let's take a look at Venus here. And Venus is the second planet from the Sun at about 0.7 AUs. It has an orbit of about 225 days, and its rotational period is 243 days. So that means a day takes longer than an actual year on Venus. And a strange thing is that it rotates actually backwards. So if you recall, nebular theory says everything should be rotating in the same direction when the cloud forms and it starts spinning. This actually ends up going backwards. So what we think is that during the heavy bombardment of the formation of the solar system, an object collided with Venus hard enough to slow it down and even make it go slightly backwards, and that's why it rotates so slowly. 900 degrees Fahrenheit all the time, everywhere on Venus, and it's covered with lots of volcanoes. So very hellish conditions. Hot volcanoes, even sulfuric acid. Not a good environment, not somewhere that's tolerable for us to go there. And we have had quite a few explorations go there, so we do know quite a bit of information about Venus. Here's a photo of the Venus atmosphere, and you could see heavy cloud there. Well, we can't really see to the surface there. So very thick atmosphere there, and those clouds kind of cover, and you get that kind of brownish color to it, that sulfuric acid that it has. Here's an image using a different part of the electromagnetic spectrum. We could see that we could actually see through the clouds with this in this wavelength here, and we could see the topography here. So higher areas kind of in reddish towards the center there, and then the deeper levels kind of in that bluish purple. You could kind of see up on top and on bottom there. So quite a bit of a different terrain there. So let's look at cratering on Venus. Every object gets bombarded in the solar system with craters here. But when we look at them, it's a lot fewer than the actual Moon, Mercury, and even Mars. Again, because the surface is being recovered with lava, right? Lava is actively flowing, and so we see those being filled back up. So very, very light cratering there. Here are some more images, some more impact craters. And again, you could see surrounding them, the edges there on that first image, fairly round. So they're getting smoothed out, getting filled in. And then on the right, you could see those that you could barely make out the actual indents. So the whole, the crater itself is kind of gone there, but you still see some evidence of that. And so Venus is covered with many volcanoes. We see evidence of the lava flowing with the few craters that are there. And this image here actually shows a twin peak here. So looking at those there. So a twin peak volcano there, active. Here we have some plumes. So we could see the volcano kind of ejecting out there across, and so you could see that eruption is actually happening there, kind of that round features there. So very vicious, slushy type lava kind of coming out through there. And we also see evidence of tectonics on Venus there. So there's these fractured kind of contours that indicate those kind of that tectonic stress there. And so we could see those here with the lava flow. Ridges and cracks as well throughout. So again, these are suggesting those stress marks. And these regions have been fractured by the tectonic forces there. Erosion on Venus. We see quite a bit of erosion there. So here the rocks being kind of broken down. You could see that. Here are some more images as well. So looking at erosion there. Again, not much as we would think, but still visible erosion there happening on the surface. And so one thing difficult with Venus is, when spacecrafts land, they typically take a photo of their feet to make sure they're on stable ground there. But the conditions there are just so difficult there. The heat just malfunctions the equipment. Spacecraft typically don't last that long there, so we're able to get a few images of the surface, but then after we lose that communication. And again, just the conditions, whether it's the sulfuric acid there, the heat, the lava, just all of that adds up together. Very, very difficult to get some of the images on the surface, but we do have a few. And so the atmosphere on Venus is very interesting because it has that runaway greenhouse effect there. So we see that there's a layer of sulfur clouds that gives it that brownish kind of haze there that it has. And so again, that sulfuric cloud will lead to sulfuric acid. So apart from the 900-degree temperatures, the lava volcano, you even have this acid rain that occurs there on Venus. So it has a very thick carbon dioxide atmosphere. The pressure is about 90 times that of Earth. And so it reflects the droplets again with the sulfuric acid. And then the upper atmosphere we see has very high winds and still kind of remains slightly unexplained why they have those high winds in that upper atmosphere. So this carbon dioxide, this is our concern with the runaway greenhouse effect on Earth, is those gases go up in the atmosphere, creates a thick atmosphere, kind of like a thick blanket, and so then that heat doesn't leave and it gets hotter and hotter. So much like if you've ever been to the mall on a hot day, you go inside and when you come back out to your car, you open that door, it's extremely hot. The sunlight has been coming in through the windshield, but then that heat was not able to escape. And so that's what caused that runaway greenhouse effect. That thick carbon dioxide atmosphere acts like that windshield. And so Earth escapes this fate because a lot of the carbon is within the water. So we looked at, I believe, back in chapter 7 or 8 when we talked about the Earth, that there is a carbon dioxide cycle as well. And so a lot of that stays within the rocks in the ocean and slowly comes out over time. So the ocean has actually helped us to not have that runaway greenhouse effect. But as we extract those that carbon dioxide, if we extract those fossil fuels, it adds to making that the carbon dioxide escape a lot faster than it should. Okay, so we see Venus has a lot of activity, very geologically active, but not a place where we could actually go there and explore. Just our body wouldn't be able to tolerate it, even with space probe. Just a very hellish conditions, not a place for us to actually be able to sustain there. So let's look at Mars. And so Mars, now we're at about 1.5 AUs, rotational periods, about 24 hours, roughly about that, the same as the Earth there. We see a lot of craters, volcanoes, riverbeds as well. And we've had quite a bit of explorations to Mars. We have a big fascination with that because we've always thought it was a place where water had flowed. And so when we talk about life outside of the Earth, one of the key features we look for is perhaps water, right? It's going to be one of those building blocks there. So just to compare Mars to the Earth, about 50% of the Earth's radius, 10% of the Earth's mass. The axis tilt that creates the seasons is roughly about the same there. And it does have an atmosphere, but very, very thin atmosphere there. The main difference, Mars is a lot smaller. But apart from that, it's still within kind of that habitable zone of where it's close enough to the, or right in that region to the sun where if you're too far, water will freeze. If you're too close, water will evaporate. Mars is kind of right within that area that Earth is, that Goldilocks range, not too cold, not too hot, but nice conditions for that liquid water. This is a map done by Percival Lowe when he first started observing Mars. And what he noticed was kind of a series of these connected canals. Now, Percival Lowe, though, believed that these canals were not naturally formed, that they were made by the inhabitants of Mars, hence Martians, and thus began our fascination with this idea of Martians living there. And, typically when we think about aliens, we think of Martians there. And so it was due to this kind of interconnected canals here, again, that they thought the inhabitants of Mars had perhaps created there. We now know, after sending rovers there and other spacecraft, Mars resembles much kind of like our Southern California desert here. And so you could see just kind of a desert there, fairly harsh terrain. Here it's kind of rockety, broken down. There is some more other geological features that are a bit more interesting here. But you could just see, even at this kind of calm, flat area, still a bit kind of unsmooth, resembles more of just kind of a desert. Here's an image on the left where you could see some of the features on the surface of Mars. And just a few months later, looking at the same region, you see that it's completely covered. So Mars has these huge dust storms. The dust is actually very fine, that it's able to be carried very long distances. But this entire side of the planet is completely covered by this storm. So extremely, extremely large dust storms. And here's an image of those, the sand dunes and that fine dust that they call dust devils. Again, that could be very, very small, and they travel long distances, and that's how those dust storms are able to get extremely large. Here's an image of Victoria crater on the left. Here we could kind of see the edges are kind of jagged a bit, so again, erosion, wind kind of filling that up there from those perhaps dust storms or so. And then here, a close-up image on the edge here. So you could see in more detail a bit more rough terrain along the edges there. Here's an image of Olympus Mons. This is the largest volcano in the solar system, which is dormant at this point here, but extremely large here, would rival that of Mount Everest, the largest mountain here on Earth. So extremely, extremely large volcano here that we see. About 6,500 kilometers across. So end to end, roughly about the size of Los Angeles. Here we see a canyon, Valley of the Mariners, when the Mariners space probe flew by here. This is about 3,000 kilometers wide and 8 kilometers deep. So this would dwarf the Grand Canyon. And so the Grand Canyon was carved out by water flow right through the Colorado River over millions of years, just a long time, right? Eating away at it. So here we see a larger canyon as well, carved out there. Here's an image of a landslide, and so we could see that all this debris there. So again, landslide, again, that means activity happening there on the surface, and we could kind of see that buildup there. This is on that canyon floor. Here's an image with a topography here. And so again, the red images on the left there, you could see are higher altitudes with volcanoes there, mountain ridges we could see. And then on the right image there towards the top, you could kind of see what resembles is perhaps here, this smooth, larger region in here, which looks that, perhaps an ocean at some point resided there in Mars. Takes up quite a bit of the terrain there. Here's an image of 3 different landing sites. And so Viking 1, Viking 2, and Pathfinders. And again, you could just see kind of the terrain very similar there. So desert, rocks there, ranging from different size, right? Tiny pebbles up to boulder size as well. Here is an image from the Pathfinder. And what we could see here is it actually shows evidence of perhaps water flowed long away. And we could just tell by the imprints that it has left on the terrain and the rocks there. And here is the water frost that we see. So frost up on top. Again, when it melts, it goes underneath the ground here. And that's the issue with water on Mars, is that we see evidence of water and actually flowing, but it all retracts back underground. So we don't have, when we talk about looking for water outside of Earth, we're talking about water on the surface. So that water goes back underneath the ground on Mars. Here's some wind erosion on Mars. So you could see the wind direction flowing these here. And these are about 1 kilometer wide here. So lots of wind erosion. And here we look at the Martian North Polar caps. So on top, those ice polar caps there. And we do have images at different times throughout the year where we see that they get smaller and larger. So in fact, that ice is thawing out. But again, the water goes underneath the surface there. And here we see runoff of outflow channels here, so that images here you could kind of see these ancient, well, actually these are more current on the right here of riverbeds, this kind of flowing there. So let me mark this up here. So this right here, we actually see the flow. And these are more current, so suggesting that there is actually flow happening now. And here we see evidence of some of these ancient water flows where at some point larger regions actually had more water flowing through there. More evidence of this. We see these kind of darker streaks here. These are several hundred meters long here. And so in a crater, and we see that flow again. So again, that liquid flowing down through there. And even here on these mountains here, we see again these downslopes, which again are just a few hundred meters wide there, and suggest that these are ongoing. So we keep seeing these reoccurring regions here. So water flow happening on and on again. Here is another image of a Curiosity rover, one of the sites where we think that there was perhaps water at some point. And looking at the rocks, the erosion here, and how they have decayed here, similar to when we look at waterways here on Earth, the rocks, the way they smooth out and the way they decay there, only happens when there's a water flow. So we see rocks that resemble that. And so this is our big fascination with Mars, is that there's a lot of evidence that there was a lot of water flow at some point. When we talk about looking for life outside of Earth, on Mars, we don't think we're going to find anything living there, Martians or anything like that. What we're looking for is evidence perhaps of past life. So in some type of fossil, perhaps even, conditions for bacteria to form. So it's a good place where there was a lot of water. It had oceans. It had flowing water on the surface. But for some reason, all of that water ended up drying up. Right now that it remains is just a desert planet, but there was lots of evidence of water there. So Mars is a good place. That's our fascination with it, to get some evidence that perhaps there was conditions for life before. And if we see that very close to us, then it's possible that we could see that in other places, right? In other places in the solar system, or perhaps even distant planets. Okay, so more interesting, those terrestrial planets, which have a lot of geological activity. And so we'll end this video lecture here.